bunch in Go will do is it will walk the graph of all the Go files in my in my imported by my application, let's say, right? So it's going to walk the whole AST, and it's going to replace all WASM imports. Normally, that's how your Go application, Go component gets some functionality. You just some exported by a runtime. It's to replace all of that with native implementation of these WASM imports. It will do it at link time. So basically, for if this runs in component mode, you get an import from from the runtime. But when you run natively, now you actually also can fulfill all these WASM imports, which normally are missing in the generated code. Like for example, if I looked at I think anywhere here, so as you can see, right? So with WASM import identity bool, like there's no limitation for it because it's assumed there's a special function which is only available, and you get it from the runtime with a special WASM import directive. And so that's the directive that the bindgen actually will parse, and it's not tied to. It doesn't actually need width to function. Right? What I'm trying to point out here is that it actually just parses source code. So it will work. For example, if you have WASM import in a dependency, it will still work, right? If you have these WASM imports scattered around the places, maybe you're using multiple widths in your project. Essentially, it will all still work because it's really just depends on Go source code, essentially, with which your component uses. And so, in order to make it all work, I have this very little bit of boilerplate, which probably is all in development. It's not complete yet, so just to make it clear. But basically, what I do here is I create a new instance, which is like that component, a stress component I showed before. I build it with cargo build right here, and I just copy paste it to my directory, and I do go embed to get those WASM bytes available, at compile time in my test package, right? Again, I'm very adding this test underscore test to make sure this never ends up in my production code. But I don't want to accidentally make a mistake here, right? So now I can use West library to create a new instance, which will essentially compile this component, the trust component, right? It will run it in WASM time, and now I'll have it available to call any function exported by the component. Yeah, so then I have this little helper here, which basically registers the error handler. Like if, for example, I try to call some function on the component which is not exported by it, I'll get an error, and I would want this error to result in an error in my, as part of my unit test, rather than just fatal exit. And that's about it. So I have all these unit tests, and I can just call these functions generated by wasmCloud Go again. And this is exactly the same functionality that I would be using in production code. Where this provides me with actually full coverage of all this code, because I'm taking exactly the same code paths as my production code would do, except that I just add some stuff to it at test time, let's say, which is replacing those WASM import with some additional functionality. Now, it's all very great. You can see it's working, and but of course, this example is sort of synthetic because, well, I'm using a custom interface, right? And I have all these custom functions, and this works great for like a command style components, which function applications with the main. But it would be great if I could also use this for example, my HTTP incoming handler, HTTP incoming handler. HTTP request handler. And it actually does work. So it's still a bit rough, and I'm working this right now. I really just got it working. But just the same way, I have right here my unit test, which it will create a new incoming request, new response out param, these resources which normally wasHTTP expects, and I can actually pass it into my implementation, my HTTP handler implementation, and just run it. So similarly, I can go to WASI, go generate, go test, and it will generate the code and it will run. There's no functionality, for example, to still get the response back and things like that. I'm still working on it all, but I'm just showing an example of it's actually working. And the cool thing about this actually is that all of these functions, which you may notice that these two things are not actually available in wasmHTTP. Like this is not something that is present in wasmHTTP. Normally, incoming request and response at param. So two resources which are created by the host and passed into the components by the host. So there's no way to actually construct it kind of in the component. But to facilitate that, I actually, again, use width. So this all functionality is defined in width. Let me show you here. This is what it does. So I have here an interface, which is exported by OS runtime and then used by my pass-through component, which essentially re-exports WASI. It re-exports all the WASI functionality which is available in the host and makes it available as a component export. But it also makes this HTTP pass-through world available with the functionality to construct a new response out param and incoming requests, which in turn is implemented in the host and using wasmTime wasmHTTP to create a new HTTP request and all that. Like it's all really real. But the cool thing here, I think, is that these two functions are actually generated using with branch and Go again, and they work exactly the same way as every other function, being handled. By the way, again, it's just an export being called on a component, and it all is passed through exactly the same way as all any other functionality. So basically, what I'm trying to say here also is this the FFI, this wrapper, actually is very thin. Like there's no need to build anything HTTP specific, for example, in my C library, because I can just use this CABI-ish API to actually call out functionality. That makes sense. What you'll think about it?
Yeah, Roman, I think there's a ton here. So what you have on screen right now, like at the bottom there, that's a test where you are like constructing an HTTP request and then calling your components export handle, and then you are then able to make assertions like based on what the component did after the fact.
Yeah, so this is the handle. That's what was presented in Go, right? This is what I'm calling right here. And I don't do it yet, right now. That's what I'm still working on. But I will be able to get a response and work with it as a normal HTTP response. I'm actually thinking if maybe there's a way to integrate with the HTTP test, which is a Go library, like standard library, which um, lets you test your HTTP services. So I still something to explore. But yes, that's the idea.
That's super cool because that seems like one of the hardest things to do right now. Like before for unit tests, we said like, oh yeah, if you take all your like functionality out of the like component export handler and then like make that into a unit test, you can test what you're doing. But it didn't like that feels so much less real than being able to construct an HTTP request that you expect to get and then like assert that changes were made. That's super cool.
Yeah. So just to reiterate, like this makes it possible to take for full coverage, to have full coverage on my production functionality. Right, in my unit test, I can exercise all the paths exactly the same way how they would be exercised, at runtime, running in the runtime, running at runtime.
That's super cool.
So actually, this relates a little bit um, to the C stuff. Brooks, remember when we do Rust and we do with bindgen, the or I'd say like the types would have the name of the world in them, and it's kind of confusing if you've just been doing wasmCloud and Rust. When the world name doesn't really appear in any of the generated types, but it does in C and it doesn't Go. And I don't want to get, I guess maybe it's too off topic, but clearly testing is the name of the world, and that's why it's showing up as the type here. And I didn't know, are we going to start saying like, hey, are we going to have to standardize the world names, or maybe is this cause for something to make us do something we don't usually do? If that makes any sense, sorry.
Gotcha.
Sorry, I'm not sure what you mean by the testing world.
Oh, the actual world, you called your world testing, right?
Let's see. I called it the world.
It was Westing test.
Wait, this is not the one. This is the one? Yeah, this is one. The world is HTTP pass-through.
Oh, I thought I saw you had another world that was called
That was the package name. But
West
normally,
test. Oh, okay, the package name.
yeah,
Okay.
yeah. So normally it's only the interface names that actually appear in the imports and module paths, for Rust.
Okay.
And I think simply for Go.
All right, just so okay. So we're gonna have this thing. It's gonna be called pass through. Does the package doesn't bindgen put the package name? Maybe it's the package name. Maybe I called my interface and my package name the same thing. So I'm losing.
Yeah, it would be the package name.
So the
So,
package name
like-
gets put into the types.
Yeah, so
in
be
the
like
generated
West
in the generated type. Okay.
Yeah, so let's look at maybe this one is be easier. So this would be West test HTTP, and then it'd be new response. Like this would be the path,
Okay.
right? So this. And actually I can show it in components. So
Yeah, just see the generated stuff. Because I think sometimes I know it's not really specifically what you're talking about, but it seems like we're gonna have to.
So West
Okay,
test right
maybe it's-
here, and then I do HTTP.
Okay.
Yeah. Here, just
Maybe it
HTTP.
works okay in Go better than I thought. Because if it works like C, it's kind of tricky.
So
the
in
actual
Go,
generated types have the name of the.
So in Go, I was actually the same. I think it's the same, right? So you have the West test HTTP, and then inside here you have the functions. So actually, it's exactly the same path.
So the function names don't just come from the functions defined in WIT, but the actual types get the package name or the world name in them. Sometimes, well, in C at least. Okay, never mind. I don't want to go.
Maybe.
I'm taking.
Oh, so maybe it's possible. It's possible that you're referring to the WIT binding Go from wasmTools.
Okay.
Is that the case?
Yes.
Right. So I'm using here the other WIT binding for Go, which is I think before it was called. I'm not sure. So wasmTools Go, I think it was called. I think now it is called something else. Maybe it's a CM Go. But anyway, it's this one. And I think it was moved now to bytecode lines. Maybe Bailey has more information on that. Lucas.
Okay, so it doesn't do that.
No.
Okay.
This is a pure Go implementation, actually, of the bindgen.
Okay.
Yeah, this has been kind of this has been more of a recent effort as far as I know to like improve one to have like a native Go implementation so you can just like go generate it, but to improve the bindgen for TinyGo. That's a statement, but I mean it more as a question. That's right, Roman and Lucas? I know you guys have been like pretty involved in the Go side.
Yeah, that's correct.
Yeah, because it's certainly so I guess back to your question, Colin, it kind of sounds like now that we've gotten some experience with generating types from WIT, like this effort is making it look nicer for Go. Like the Rust one feels really nice because it's like all module scoped.
Yeah.
And like a similar effort could happen, like could be taken under with C, so that it's not like all the types having so the types are like properly separated instead of just like all being in the name. Yeah.
Yeah, dumped into the same namespace. Okay.
Cool. Well, yeah, so Roman, is there any call to action right now, like a way that we can use this? I know that you mentioned it's still kind of POC and you wanted to work on a couple of things. But yeah, this seems super cool. And I was wondering if I could try it.
Well, if you're feeling very adventurous, you surely can try it. So by the end of this Friday is the deadline I put for myself to actually publish it and make it usable for people. The only tricky challenge here is actually for now to build this platform harness, right? Like this thing which re-exports WASI essentially. I was hoping to be able to reuse functionality from like the virtual adapter from wasmVirt, which does kind of the same thing. Like it's built on top of that adapter. So I tried to use that, but I think it's not going to work like out of the box. Now I have to build my own adapter of such sort. So what I'm trying to say is that if you want to use this with just a custom interface, that would you can already use it basically today. But if you want to use, WASI-IO and WASI, HTTP, WASI sockets, and all that functionality available in WASI, so you'll have to wait, I think, for next week when I can publish, some functionality to actually build such a construct. Like, for example, if you want to have a custom interface and WASI, and you want to put the two in one component, so that's the tricky part, which I'm working on essentially right now.
Okay, cool. Sorry, I monopolized some of the questions. Do folks have other questions? We'll take a couple more minutes of questions before we move on. For Roman. Alrighty. Well, thank you, Roman. Looking forward to, well, Friday. It'll definitely be done. And maybe we could do an update next week in the community call or something during our innovation day to see how it's going.
Yeah.
Sweet. All right. Then I think what we can do is, oh, and Roman just shared the POC link in the chat, so we'll try to put that on the YouTube as well. Speaking of Go, why don't we? I don't have it on the agenda still, so I'm not even going to bother sharing my screen. Lucas, you have been working on a essentially like a component SDK for Go, and you said you were willing to share some updates. Take it away.
All right. See my screen fine?
Yeah, looks good.
Awesome. So what I'm gonna show here is this is the current examples that we have in wasmCloud for Hello World, and talking a bit about the differences from the way that we're doing with bindgen today to the future, and kind of it's similar to what Roman just showed using the with bindgen in Go. So the current one that we have in wasmCloud, the existing one, if you take a look at the code that is generated, it's gonna generate you some Go files and also some C files. And this is pretty much how with bindgen works today. If we look at a component that uses with bindgen Go, what you're gonna see are a different set of files that will be more with 3. That will pretty much be 100% Go. So C has kind of left the building, at least in this scope. And this means that we're now using a different bindgen that is being hosted here in Bytecode Alliance Wasm Tools Go. And sorry, Liam, you have your hands up?
Yeah, I just want to maybe start with maybe a couple of something a little more basic. So I would use this if I wanted to build a component, a standard WebAssembly component that's in Go. Is that right?
That's right. Yeah.
Okay. All right. So this is the workflow that I would use, and you're showing me it looks like a Go native way to do this. So an idiomatic way to build Go native WebAssembly components. Is that what you're essentially showing me here?
Correct. Yeah. So pretty much tracing where we are today and now where this is going.
Great. All right. That's awesome. All right. I'll go back on mute. Thanks.
Thank you. Yeah. So the way that we do it today is in our file, in our component file, we're going to have a Go generate call out here to with bindgen. And we specify which world we want to export, which directory, and so on. If we look at a new style of doing components that are more native to Go. We're going to have the exact same thing, but instead of calling with bindgen, we're calling with bindgen Go. So in terms of how is this going to change in getting started with components, it doesn't change much. Is a different Go generate line that we're going to use going forward. The interesting part is back to the existing way the components exist in Go. If we take a look at the interfaces, the names, and even the verbosity of these components, there's a lot. So you end up with code that is somewhat hard to read at the end of the day. When we look at the new generator, we can pretty much think that this is generating to us things that are more Go-like. So if I'm interacting with any WASI object, I'm not going to have the WASI 2.0 package name, underline this, underline that. They are actually scoped to the correct Go package, and they have their actual names. So when talking streams, input stream, you have a package stream and struct input stream inside that thing. And this is kind of jumping a bit ahead because it's part of the component SDK. And this is to say that today there is no such thing as a component SDK. What you have is with bindgen, and you go and implement the with contract yourself. What we're looking at here is something that is still experimental and is hosted under wasmCloud component SDK Go. Let me paste that here. And what this is providing some helpers to facilitate writing components in Go and focus on bringing the nice features from the standard library that we have in Go over to the component model, over to WASI. So what this is giving us here is a way to interact with WASI HTTP in an easier way. So it will make WASI HTTP look more Go native. So instead of interacting with incoming handler, outgoing handler, you can interact directly with HTTP server, HTTP round tripper. And we are also giving here an abstraction, an slog abstraction on top of WASI logging. If you are used to do structured logging using slog, this is probably going to be quite useful. And how does it change things? So where before we had a hello world in Go that looked something like this, now they're going to look more like a, let's get one that is an easy one here, Lucas. This one here, the headers one. So these are how components in Go will look like. They are literally the handler from HTTP. What I have in the screen here, it's a sample components that is also in the component repo here under examples. So if anybody wants to take a look later on, you can jump here. And what it's giving us is something quite basic, but it's highlighting some of the challenges in developing components in Go. So this component here is giving us how do I read user headers and also set server headers. So for that, we can take a look at the headers endpoint. And the headers endpoint is giving us our user agent here, which was coming from the client, is spitting that back out to us as a server header. If you want to see how errors would be generated, it would be something like this. And why are these things important? If you see the error handler here, for example, there's no WASI at all. So we are pretty much using standard Go library again to interact with components. The one that I like the most is coming up, but this is also pretty interesting. When parsing body data or query strings, Go has this concept of a form, and forms are also possible in this component model. And in order to parse them, again, you're going to parse a form just regularly like you do in any other web server in Go. One of the largest challenges in implementing NetHTTP, the WASI NetHTTP, is that streams are important. You see a lot of attempts to do this thing here that will actually stall once you try to send large files, mostly because in components, we have linear memory, so it's a very limited environment. So the ability to stream is quite important. And for that, we have here an endpoint called post. And what it does, it echoes back whatever we post to it. So in here, I'm posting just this, that, and I get back this, that. I do have a large file here, which is about, I think, 6 megs or something like that. And I can pipe that to this endpoint via curl, by telling curl to suck in that file, and it works. So this is pretty much to say that even streaming is possible in Go with components by using this component SDK. And what the component SDK is giving us here is literally facilities around streams and WASI HTTP. So it's not using any special sauce. It's not doing anything that is specific to wasmCloud. If you have another runtime that is capable of fulfilling the WASI HTTP contract, this will also work in there. The one that is also in here, so HTTP I think is the large one. The other interesting thing that is in here is the logger. So we can get a logger from the component SDK and just use it as any other slog handler. These things here, once you add a log in your component, they will go out to the wasmCloud host log and also to traces. And in here I have a wasmCloud instance up, and we can see a log event. We have the key value pairs being put as key value pairs. And if you're using Splunk to load this data, Splunk will parse these key value pairs directly for you. And this is also taking care of setting the context, so you know where that log message came from. So this is pretty much the first steps here in getting a component SDK for Go up and running. And we want this to not include any special sauce. We want this to be reusable. And long-term, as the WASI spec matures, as things get better, this component SDK might start removing features from it. So it's pretty much making sure that we bridge here where we are today with the future. And as things are getting better, maybe the component SDK will not be needed in the future. But for now, it helps a lot. And that's all I have.
That's all I had. I have questions, but I will go later. Do folks have questions for Lucas?
When's it going to be done?
Friday. Is the new deadline date?
It is amazing. That's not a question.
Hey, this is Ritesh. So Lucas, this is great. This is something that we were looking forward to. So thank you for implementing this, and we are all curious to see how if there are some examples that we can refer to. But on Friday, I guess. Yeah.
Awesome. Yeah. I'm getting some examples up, and right now the one that I just went through is in the repo, and we're gonna be adding more to them. We're also looking here how far we push it. We don't want to to make everybody kind of require the component SDK to develop. So we still want this to be part of the WASI standard. But if you have any ideas for the kind of examples you would like to see in there, I'm open for ideas.
No, regular, mainly HTTP client and streaming, because that was one of the things that we were looking forward to. Yeah.
Thank you. That's a great segue. There is one other demo that I can put that in the repo quite quickly, which is doing a proxy, which is you implementing the incoming handler and also the outgoing handler in a way that you can write an HTTP proxy as a component. So I'll get that one up because I think it's probably useful in many different use cases.
Just to reiterate, this was HTTP and logging. Those are the interfaces that this implements. Do you intend,
Correct.
right? Okay. Do you intend to do any of the other standard WASI interfaces beyond that?
For the time being, I think we'll provide some helpers for streams and make sure that these are all solid, tested, and so on, and then reassess.
Okay.
Just like
So
Go
you
ahead.
must have already had. Oh, you mean like P3 or whatever streams, or do you, because HTTP already has streams in
Correct.
it, right?
Yes.
As current
It's
streams.
correct. It's pretty much providing facilities to manipulate streams in an easier way. So it's converting an input stream to a reader closer, converting outgoing stream to a writer closer. So those kind of helpers.
Yeah, speaking of Lucas, so I was looking at this example, which now I'm gonna ask the question because I can't wait anymore. I was looking at this example and like I can see that you're generally like using IO net HTTP strings. I was wondering where this component SDK really comes in. Like what it actually does, because for the bulk of this component, it looks like pretty standard component code. Like in general, I guess correct me if I'm wrong. I can see that we import like the WASI HTTP implementation here and like call this function. Um, does this just does this convert the WASI HTTP like incoming handler into like the standard HTTP types? Is that how this works?
That's correct. So we're using the with bind Go from the Bytecode Alliance repository, and it generates a set of standard interfaces. And we are sitting in between, the component SDK is sitting in between with bind Go and your code. So it's providing you the adaptation layer there. And this also shows that it's possible to do this without actually having to implement all this in TinyGo or BigGo.
Awesome. Awesome. And then the only other place that I see our SDK getting used here is the like the slog implementation. That part is in the SDK, right? Okay.
That's correct. Yes.
Okay. Awesome. I mean, I feel like the like setting up this init function and then just getting to work with the HTTP response writer and a request pointer, like that's sweet.
And we're going to do the same for providers. But next
Ooh.
week.
Yeah, next Friday. I have another question while I'm here. Sorry. I wanted to know because we've seen wasmTools Go used here, like in your demo and in Roman's demo. Should we change our Go component examples just to use wasmTools Go? Like I know that this SDK is under development and so is West, but like is wasmTools Go ready to go now? Should we just change our TinyGo examples to use that instead of the whip-bind generate?
I think we should. It's way easier to reason with. It doesn't come with the C code. The naming is better. I think it's totally valid.
Okay.
I'd recommend waiting for the vanity URL to land. That hasn't happened yet. That way we can refactor some of these pieces without breaking people who have copied from the examples.
Okay. Yeah, I think that sounds like a good idea. I'll get this filed as an issue then in the wasmCloud repo. Tagging it that it's touching our Go examples and that it's something we should do once the vanity URL is ready. I think that would be great. I mean, wholesale, the examples that you guys have shown today look really nice on the Go side. Okay. Okay. Do folks have other questions for Lucas on the Go side? All right. Well, definitely more to come here. I think everybody can keep an eye out for us to complete these couple of issues and convert our Go examples over to use these new SDKs and testing frameworks. I think that it's incredibly impressive what you guys have put together, and like it looks like, and I guess just is normal Go code that compiles to a component and isn't something that has to tie you to wasmCloud specifically because it's just using all the standard interfaces. And I think that that's just it's all just a slam dunk. It's super exciting to see it all come together. So I think everybody will get to see and use this pretty soon, which is really exciting. All right. Well, now I get to take over for the coolest part of the community call, which is checking over our roadmap and talking about the progress there. I'll try not to put everybody to sleep through the end of this. I just wanted to call out because we are getting towards the middle of September, how our Q3 roadmap has been going. As usual, essentially as expected, we've taken on a ton of work, just like quarter two. And there is, we've been making steady progress to this roadmap, which is essentially pretty well scoped down for compared to quarter two to make sure that we're completing what we plan to do and then moving on from there. So go ahead and start thinking. We're going to go ahead and start thinking about what we want to get done in quarter four. But just to give you all an idea, been a couple little tasks that haven't quite moved from the beginning, and that's okay. Expect maybe one or two tasks from the roadmap just to not be as necessary as we move forward. But we have a ton of work in progress right now around sharing components and providers, custom interface functions with resources. I saw a PR from Masood or OSS Fellow for consolidating the wasmCloud Helm charts, which is going great. I know Ahmed is working on the application events on the Wadham topic. Victor has been putting in PRs this week for Watch Dev. Ditya took some of the work on implementing WASI Key Value Watch. Like a ton of this is in progress and moving forward, which is really great to see. So great progress on the quarter three roadmap. And really all I can say is thank you everyone for taking some of the issues here. I mean, you can see a huge range of little profile pictures for who's assigned for getting these things done, and it's because it's getting done by community members, and that's really awesome. Community members and maintainers alike. We're not just sitting over here twiddling our thumbs. So I think that's great. Quarter three roadmap's going really, really well, and just take we'll check in probably the week before for a last second bug bash or so, but we'll start getting planning on the quarter four side. I don't think there's really much to ask questions about. Feel free to raise your hand if you had anything about the roadmap, but I think we can go ahead and transition into the general time. So we've got some time for, oh yeah, Masood, go ahead.
Hi, Brooks. Regarding roadmap and that item about packaging providers as OCI artifacts.
Yep.
That I looked into it, and again, in my assessment, it requires kind of a loose spec, because if we want this to kind of be future compatible or near compatible, then we have to have some ideas about how having multiple artifacts which have different targets indeed, because that's also important. You know, when you're looking at the current specs, it's talk about target being part of the config. And here we have packages that have different targets. So we have to have some ideas about what that looked like before we say that what we're going to implement here. That's at least my understanding. Maybe I'm wrong.
Yeah, I understand. So there are a couple of improvements that I think we want to make to providers being pushed up to OCI. You know, we've talked for a little while about putting targets in different layers. But I think that for this issue, all we wanted to do was take the same config format from the OCI WASM artifact, and use that for providers instead of kind of our own, you know, essentially made up configuration media type. I think that there's also an aspect of this where we want to store the WIT alongside the provider as well in OCI. But I think that Taylor is really the champion here. So I'll hand it to you because you raised your hand if you want to say more.
Yeah. The whole purpose of this is not an elegant solution, it's a stopgap. Or not, it's not even technically a stopgap. It is going to be a thing that hopefully, as WebAssembly continues to mature, becomes less and less of a thing. Like there's a distinct possibility that once we get threads and everything, we could have an HTTP provider that's just a component. You know, I mean, it's still a special kind of component, it's still a provider, and expects state and more privileged access to things. But for now, this is just like we use the exact same config format, so that lets us describe the WIT in the config format, and then each layer can just be named with a specific naming convention. And then when we pull it down, the manifest down, we can look, find the thing that matches the target according to the naming specification, and pull that one blob from the manifest. Like this is supposed to be like just a drop dead simple. The work here that I thought's complicated is actually doing like changing the stuff inside of the host and other things to be able to know to handle both the old style of provider thing where it's just one big tarball, and then this newer thing for the next few versions. Well, it'll have to be backwards compat because it's in the host until 2.0. Until 2.0, in which case we can move on to the new one. So this isn't meant to be something super fancy or entirely complex. It's just saying each layer is a binary. It has a specific naming format so that you can know like, oh, this is like Linux-AND64, just like we have right now inside of a tarball. And then we have the WIT stuff inside of the config, just like it is for an OCI component. Just we parse it out from when you're building the provider instead. So that's the sum total of this. It's not supposed to be anything more complex than that. It's just meant to be a different representation of the tarball. Instead of the tarball being a tarball, it's now a manifest, and each of the blobs are stored separately.
So I'll ask some questions over the Slack, and if I understood, you know, what you want, then I'll implement it.
Okay, awesome. Thanks.
Okay. Yeah, that seems super fair. Thank you. Thank you for the question. Okay. So yeah, I was transitioning over to updates from the general WebAssembly ecosystem, which I guess pretty much most of our call today was, which is cool, or general wasmCloud things. And I think, not to be unfair, but Taylor has kind of preceded some updates in this area. So Taylor, yeah, let me give you co-host too.
Yeah. Okay. I am excited to show some stuff off here. It's not like this isn't particularly impressive. I'm just excited because it's been months in the making and lots of community collaboration and whatnot. But we're basically what it boils down to is we now have OCI support, all the OCI artifact support in mainline WASM tooling stuff. That's what it boils down to. So let me pull up the right repo first. I didn't have the right one up, but I did. Okay, so let me share my screen. So there is this thing I think I've mentioned before, linked before. It's called WASM package tools with a CLI that's called Wackage or WKG. You can now install it. We don't have it through like a homebrew or anything like that yet if you're on a Mac or whatever. But we do have binary releases inside of the release, and we have the ability to cargo install this. And this Wackage tool chain is the core of a lot of the WebAssembly tooling that's moving forward. For example, componentize.net is using this to fetch dependencies. And essentially what it boils down to is like so if you have WKG, you'll see here you have get, publish, and then OCI. If you're working in an entire wash already, essentially the OCI command is exactly what wash does. If you're using wash push, except it doesn't support providers, obviously. It only supports components. And so Wackage OCI is something that everybody can use to pull or push a binary, like one of the ones we'd execute inside of like a component we'd be executing. The get and publish commands allow you to fetch things based on the namespace and package that you have as a configuration. And so if I go Wackage get, and let me remember the thing I have to do. Okay, yeah, it does default. Okay, so if I do Wackage get WASI HTTP, and then I do at 0.2.0. Okay, so that shouldn't be a warn. Well, I'll fix that later. So anyway, now if I do WASM tools component with WASI HTTP2, you'll see that. Oh, I didn't do the full pull down. So anyway, you can pull down a package and it now has that WASI HTTP in there. So this isn't like I can actually do this with random probably to make it actually work properly. Guess WASI random wasn't pushed. Okay, doesn't matter. Of course, I'm doing this on the fly in case you didn't realize. So anyway, all this Wackage stuff is there. What matters is you're probably not going to be using the CLI for this. What does matter is that this is already integrated into tools such as Cargo Component. So if you use Cargo Component now, by default, it's going to be fetching these things from the upstream OCI registry. That's inside of WebAssembly. And you're able to provide config and things. There's whole documentation here. We're going to be improving it and adding some things to config. I've already been getting feedback from people in the community, which is great. That allows you to say like, oh, for this namespace of a package, go fetch it from here. For this namespace of a package, go fetch it from here. So all of those things are now on there. So essentially, we're getting this tooling into everywhere that we can. I know that the Go folks are aware of it as well. And everything will be, we're hoping that the main like minimum integration here is that everyone can integrate in with the everyone can integrate into this config file. So even if you're writing something in your own language tool chain, you can use this config file to configure your credentials properly and then basically authenticate and pull things down. I do have things in progress right now, which is this is the next step. This is, like I said, it's not there yet. It's something I'm working on and should have done in a week or two. But I am working on adding in support for essentially a lock file and automatically fetching dependencies from your world. So rather than having like the wit depths thing that you've seen sometimes run in our components or having to manually copy paste, what it's going to do is look at your world, fetch all the packages that it references in there, and then or grab all the list of that and then use that to fetch every single package using this registry package tooling that I just showed off. And then it'll generate a lock file with the SHAs so that it can keep them around and keep them cached, and you can say like it's locked to this version, and then it will automatically populate your your deps directory inside of the wit folder And you'll no longer have to commit that. It'll work just like any other dependency management tool where it'll fetch it and build that out for you. And we'll be integrating that tooling. So that'll be available inside of Wackage to use plain with anything. It doesn't matter which language. And then you can use it with your bindgen tooling that's already there. And for tools like wash build or inside a card component, it'll handle it internally to that, or it'll do it automatically for you within wash build. So wash build will take these open source tools, use it, and generate your wit deps automatically. And so the lock file will also be shared across languages because it's just components, so they're working in any of the languages. So that's where the future of this is going. So we're looking at a world where it's now pretty much transparent to you, especially if you're using the open source stuff, and then with some minor configuration for internal things as well. So if you have like your internal company registry of these things, you'll be able to configure that, and then it'll still just automatically pull that. Lucas asked a good question here. Let me share that tab. So how does Wackage know where all of this is like coming from? Where's it pulling all the wit and world dependencies from? So the chain here is not perfect. It's inspired by some previous art. But essentially what you do is you have everything that's labeled has a namespace, right? So you have wasm colon whatever, and wasm is the namespace. So if you have a package like example colon foo, then that would be the namespace of example. And so what this does is it allows you to specify a URL, and that URL has to have a well-known file at the top. So if I had that example.com, it would look for well-known wasm package registry.json, and it will spit out what it does. So most of them here at the beginning are going to be saying preferred protocol OCI, and then they'll have this OCI block. What I'm planning on doing, which I'm not going to do right now, this is not a wackage.toml. So, man, you guys are asking all the good, right questions here, and I do have answers for all of them. So this is a common config file that's at basically xdg config home by default. And this is like the path where you would find it. And so what I am going to be doing is allowing you to basically skip the well-known by having these these config blocks as an option for this instead. So it'll be just like if you're used to cargo.toml, where you can say like, oh, here's my version, or here's like a full complex config object. And we'll do that inside of here, and you'll be able to specify like, oh, this thing maps to this specific registry. This documentation on here also has how you're supposed to store these inside of OCI. They do have to, for using this as packages, not as runnable components that like you'd run in. Those can be anything, because we're just using the direct registry URL inside of wasmCloud. But if you're doing something that's like a package, like a WIT package that you could pull down, then you'll be able to do this. So we'll be actually pushing up all of our WIT packages up as OCI. And we'll be transitioning everything to use that as soon as we get this tooling landed. So you're not going to have these tarballs or other like one-off pipelines that we have. We're going to have just something that packages it into an OCI registry. Now, as for a wackage.tom and a wackage.lock, a wackage.lock will be generated automatically and by any tooling is the goal, so that you can specify like here's the dependencies I have chosen to pull down for. Yeah, wasmCloud.toml could probably have that in it as well. There's some interesting things, but wackage.toml is entirely optional because you can pull it from the world file. What it looks like right now, I think I have this code up and can share it. Yes, I do. Let me switch screens. There we are. Okay, sorry. Took me a second. Yes, exactly. Jonas is saying some things about how there's having 7 different tools is not a thing. There's ongoing debate because also having one giant mega tool like wasm tools is also very confusing. So anyway, going to be having that debate at upcoming Bytecode Alliance thing, and just chat with some people while I'm there. But yes, Wash is always meant to be that. In case you're new to the wasmCloud community or watching this call for the first time, everything wasmCloud does is standards first. So even if you're using Wash, under the hood, we're just using all the same tools in their library form. So we're not doing anything special. We aren't doing anything like that's only for wasmCloud. We're just consuming these tools and using them inside of Wash. So anyway, basically what the whackage.toml is for overrides. And an override can be, and then also adding additional metadata that you might want to decorate a WIT package with. Once again, these are entirely optional. If you're running in like a language toolchain like Rust, it'll populate things like metadata automatically. The override lets you specify a path if something is local on disk, whether for development purposes or whatever. And those that are, and then Colin asked the question, well, how does it tell what's different for like something that's local versus something that isn't? If you look at any of the examples in the repo, which I'm just pulling up right now. Dog fetcher's a good one. Okay, let me share that now. Okay, so inside of dog fetcher, actually no, sorry, dog fetcher is not. Is it lobby? One of these has it. Echo messaging. Am I missing? Anyway, most of the time when you have a component, most of these are just using worlds, but the way that it expects to work is inside this top level WIT directory. Anything that's in there is a local package. So if you have a dependency on a package that's elsewhere on your machine, you'll use those overrides I'm talking about. Then so sorry, when you do it that way, you're going to be like saying, oh, here's my override for this thing. You're pulling it from a local dependency. You can also have like an entirely, the whackage config stuff allows you to specify like an entirely local instance where you have it just a bunch of things inside of a directory, and then you can override it all from there. But anything that's inside of here will be part of the package that you're defining. So if I had another file here, I would create a like my custom.wit or whatever, and I'd have another interface in there that's defined that's part of the wasmCloud demo package in this case. And then things around this are going to continue evolving. Like technically we can report these, we could record these as a single, like there's some interesting things. I'm not going to go down those rabbit holes right now. Ritesh asked a question about like when WIT is an OCI artifact, how I extract the actual WIT from this OCI artifact and view it as a file. That is actually going to be built in. So you can already do that with, I might even do it with the whackage kit. Let me check before I, okay, yeah. So let me share. Guess I should just keep sharing my whole screen. And no, it doesn't have to be a whole tool. I'm just showing you that like whackage has it built in there. The thing is when things like Wash or whatever use this, they can output it directly to the WIT. And when you do like a Wash inspect, you're just doing the same thing. You're just printing the WIT from the inside, which is done via a library. So yeah, like I'm just going to show this with whackage because I think I can do it.
Hey, Taylor, one thing to add here is to talk about how a WebAssembly component itself is self-definable. So one of our goals is to be able to cast from a single .wasm that represents a WIT package to this OCI manifest form and back again.
Yeah, that's an important thing here. We can get these. You can keep going back and forth. Do the introspectability of WASM. Like I can take a component and I can tell you what its WIT is. I can take a WIT package and then output the text file, and I can go from text to package or package to text back and forth. I think this is also if I do less WASI HTTP WIT. Yeah, there you go. So
when folks ask for how do I get the WIT, oftentimes the question that you're actually asking is how do I get the WASM?
Yes. And that's a key point. Like the WIT is represented within the WASM itself, and that's what packaging this as an OCI artifact is doing. It's just taking that representation and putting it into a binary format.
Okay, because when I previously made a made a PR to the Bytecode Alliance, I got the message that they want to keep the WASM and the WIT separate, like because when you want to get the WIT, you don't necessarily have to get the WASM, is what I think someone from the Bytecode Alliance had given a comment to me.
Yeah, I'd have to probably look at for more context there, Ritesh. But in general, like there's the reason why Whackage is a separate tool is because the argument was saying this tool is registry aware. And I think that might be some of their concerns. They don't want to have to like pull in the registry stuff necessarily if you're just trying to print WIT. But I'd have to
For
see more
example,
context.
yeah, for example, if I just want to generate the bindings, right? I don't need the entire WASM. I just need the WIT at that time. So now today I go and just use WIT depths or copy the WIT. Now with the OCI artifact, I need another tool, right?
No, that's the point, is this is going to be integrated in directly. So so the workflow will be more like this. So if I go to an example, let me go to the wasmCloud examples. So here's like the hello world example. And right now inside my directory, I have my WIT folder. So I'll still have my WIT folder. So if I do WIT world.wit, let's just say I was going to come in here and add like WASI key value. So instead of doing in the WIT depths directory or the WIT depths file, what I will do is instead come down here and say, okay, I'm going to import WASI key value /store at 0.2.0 draft. And so then I would do this. And now, once again, this doesn't exist right now because I am working on it. But then what I would do inside of here is just inside of wash build, or if you're not using wash, you have Whackage or wasm tools or whatever. What I can do is say, like I would say like wash build, and it will automatically go through and fetch. And actually, Brooks has a branch that does this. I don't know if he still has it running and could show this running. Brooks, I'll give you I'll delay for a second so you can you can show that off. But essentially, I'd run a wash build, and it'll look at that WIT thing. It'll then go and pull the dependency and put it down into a format that's acceptable for this. In this case, it would print out the WIT for you. So when I say like WIT, you're not having to fetch a massive binary to get it. You're just getting a the textual representation of WIT that has been encoded into the WASM binary format for portability. And it's got its own like markers on it that lets it know that it's a WIT package. So there's nothing special here. You're still fetching it, and it's much easier than trying to like pass around text files across all these things. This allows it, like this tooling will do all the dependency fetching, and the dependency tree stuff is the long-term plan here. And hopefully I delayed long enough for Brooks to pull up his branch. Maybe.
I pulled it up, but my local cargo thing is blocking waiting to build, which is sad.
Yeah, but we can show it off if we need to in a sec. But essentially, there's nothing extra here. Like this is not, for all intents and purposes, this is a transparent change. It changes how you're like if you're creating your own interface, how you package that interface up. But the tooling here is meant to be able to pull this down and handle it. I don't want to add an extra tool. That's why all of this stuff is being done as libraries. So it will be pulled directly into Wash in our case. People who are already using it as a CLI like componentize.net can use it that way. Go is kind of doing a hybrid of it. The thing that matters here is that we're just using those same things, the same config files to fetch. WIT bindgen it won't be. That's just bindgenning. Colin asked that question if it's going to be built into WIT bindgen, and the answer is I'm pretty sure no. But it is going to be other tools such as like Whack and all those things where you can glue things together will have the tooling built into that. Just be as registry. If something should be registry aware, it'll use this tooling to be registry aware.
Yeah, I have a follow-up question.
End-to-end demo, if you go to the Bytecode Alliance community stream, James Sturdivant did an end-to-end demo using componentize.net of both pulling in a WIT package, generating bindings from it for C#.net, and then pushing that component itself back up at the end.
Okay. Yeah, I have a follow-up question on that. Today, let's assume that I'm using wasmCloud, right? And I'm using the key value interface. So I'm writing a function, I'm using the key value interface, but in reality, what is happening is I'm actually only using the wit because what I'm using is a link and I'm using a provider, right?
Mhm.
So now I'm using key value as an example. Now, instead of just pulling the wit, if I'm pulling the actual wasm now with this approach, am I not pulling additional data or bytecode in my code than what I need?
Yeah, you're not like I said, the thing here is it's just taking that textual representation and putting it into the like encoding it as a WebAssembly binary. There's no additional data here. It is literally just the wit and the
Okay.
decorator to say that it's a component. So like it's basically the binary representation of it. It might even technically be lighter weight, but it might just be the text. I'm not actually
Okay.
familiar with the underlying encoding.
Oh, so you actually convert just a wit into a binary or a wasm?
Yes. Yes. So
Interesting.
that thing I was showing before is the exact output of that file, and that's what Bailey was trying to
Okay.
that was what Bailey was trying to say. Like these things are interpretable, but you can turn any component into its wit, whether that's a full component that has a bunch of business logic in it, or
Mhm.
it's just the wit. And you can take plain wit and turn that into a component for portability that can then be used as an artifact, and then that can be turned back into wit. And so it's just a different representation of the exact same text. You're not getting extra things. You're not
Mm.
pulling down an extra dependency. It's just the wit.
Interesting. Now, if I have a component that performs encryption, right? I create this component, WebAssembly component that performs encryption. I'll actually create a wit on how to use this component, and I'll build this component itself. Now, when somebody wants to use this component, right? They may use it in two ways. They may want to compose my entire component, or they may want to use, in another component, I might want to use it as a link. Now, when I want to use it as a link, if I'm actually this artifact that I have, right? The entire artifact, if I just provide the wasm that I generate, the WebAssembly component, I can obviously view the wit because, I can use wasm tools, for example, to view the wit of this one. And uh, but if I just want to use it as a link, all I need is the wit. So the way I publish, am I publishing two different artifacts? One, I'm publishing the wit, and second, I'm publishing the wit with the actual composed component, or do I just publish one component? What's the right thing to do?
It's your choice, actually. That's the good thing about it. I mean, I personally, if you're going to
Mm,
have an interface that other people are using, I'd publish the interface thing as its
mm,
own separate thing, and then I'd publish
mm.
the component separately.
Okay.
But theoretically, inside of like a big company, let's say
Mm,
Team A creates this like service thingy that they're doing, but they just thought it was going to be for themselves, and then
yeah.
they publish that and they have their own custom interface. But then Team B is like, oh hey, I want to either call that or implement that.
Mm,
Um, you don't have to go to that team and force them to like publish a full component. They can go fetch that
yeah.
component and use that wit instead.
Yeah, without a proper naming convention, that will become very confusing because people will not know whether it's just a wit or whether it's an entire component. Is there something that you guys have thought about on how you can make it clear to folks when you are publishing these artifacts? Because it looks like, we don't know whether it is an artifact is just a wit or whether it's a complete WebAssembly component. It's an OCI artifact.
Yeah, that's why there's been things about WebAssembly specific or WebAssembly aware registries that kind of solve that problem.
Okay.
We can talk about adding that into as an addition to the OCI part of this that goes inside of the config. But I think what we do is we see how people are using it, what kind of confusion and problems they have, and then respond to those needs so that it's the right solution.
Okay. Thank you.
Yeah, I think there's plenty more to talk about here, but I want to go ahead and interrupt here to make sure that we can end on a timely note. We can definitely keep talking about this in the Slack, or if there's It sounds like there's more discussion. We can tee this up for more discussion next week as well. However, I do want to make sure before we head out that I call out about wasmCloud Innovation Day next week. wasmCloud Weekly is going to be in a different time slot than usual. It's usually 1 to 2 p.m. Eastern time, and it will be 10 to 11 a.m. Eastern time. So I think we can maybe throw something up here for time zones. But just to note that this will be at a different time and accessible with a different link as well. For wasmCloud Innovation Day, we're going to be doing a Zoom webinar because we're going to be having a ton of people presenting. We're going to have a bunch of different presentations. We will still be live streaming it to the same channels that we do normally, but please make sure that you're paying attention. If you normally attend the wasmCloud community meeting via Zoom, just take a look in our Slack and on this page for an updated link and to check in around that time. This is your regularly scheduled reminder to register for wasmCloud Innovation Day if you haven't yet. Should be a great time. So I just want to make sure that I call that out. Make sure to take a look at the new link. We will be streaming and everything at the normal time, but if you come into the wasmCloud community meeting at the normal time, you may find it slightly more empty than usual. All right, folks. Well, I think we've taken plenty of your time today, but this was a great community meeting. Thank you all for coming and asking questions and being great community members. All right. Have a wasmCloud day.